This is my beginning algebra course. Today we're going to continue to factor algebraic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now today we're going to take all the types of factoring that we learned in the previous classes and we're going to combine them. We learned how to factor out a greatest common factor. We learned how to factor a quadratic expression and the difference of two squares. We learned factoring by grouping. We learned how to factor the special type of expression where you have a fourth power and a second power variable. And we learned how to factor expressions with two variables. So I think that's 6 if I counted that correctly. So we're going to combine all of those types of factoring. So let's get started. In all the problems that we're going to do today, the first step is going to be to factor out the greatest common factor. So we have to figure out what number goes into 6, 18, and 12. The biggest number, not just any number, because we know 2 goes into all those numbers because they're all even, so 2 must go into them. But there's a bigger number that goes into all those. So we have to find the greatest common factor, which is 6. And we have to factor out the greatest common factor for the x's, and that's just going to be the smallest power. So we learned this in a previous class. So now we just ask 6x squared times what is equal to 6x to the fourth. And obviously that would just be x squared. 6x squared times what equals 18x cubed. So obviously that would be 3 because 6 times 3 is 18. And then we need 1x because x squared times x is x cubed. And 6x squared times what equals 12x squared. And obviously there's got to be a 2 because 6 times 2 is 12. And we don't need any x's on that last term. So we factored out the greatest common factor. But now we have a quadratic expression. So we can continue to factor because we're going to need to factor that quadratic expression also. It's very important in this class that you factor completely. If we leave it, if we write this as the answer, it's not going to, the expression is not factored completely. So you have to take that quadratic, and when you have a quadratic, you write 2 pairs of parentheses. And we have x squared, so it's going to be x and x. And now, again, if you remember, when you factor a quadratic, you ask what 2 numbers multiply to this number and add up to that number. If there's no coefficient here, if there's a coefficient in front of the x squared term, then that doesn't necessarily work. But we don't have a coefficient, so we can just ask what 2 numbers multiply to 2 and add up to 3. So obviously it would be 1 and 2. So that's the answer for number 1. All right, so number 2, notice that we don't have 3 terms. We only have 2 terms. So this is going to be a problem where we're going to end up factoring the difference of 2 squares. But again, the first step is always to factor out the greatest common factor. So that would be, let's see, I think that's going to be 3y. And that would be 4y squared and 9. And so we factor out the greatest common factor, and you can see we have the difference of 2 squares. Again, we learned how to factor the difference of 2 squares in a previous class. So when you have the difference of 2 squares, you put two pairs of parentheses, and we know it's a difference of 2 squares because we have a square here, and 4 is also a perfect square because 2 times 2 is 4, and 9 is a perfect square because 3 times 3 is 9. So because it's 2y squared, we write 2y and 2y. And because it's 9, we write 3 and 3. And then remember, when you have a difference of 2 squares, it's always plus and minus. You always write a plus sign and a minus sign. All right, so let's try a couple more of these again here. So we have 3 terms, so this is probably going to be a quadratic. But there's something a little different on this one. There's a negative sign on the first term. Whenever you have a negative sign on the first term, it's convenient to go ahead and factor out a negative. Now you don't have to factor out a negative, but it just makes it a lot easier. So I'm going to be sure to factor out that negative, and I think the greatest common constant is -4, and the smallest power is x to the 6th. And let's see, that would be I think that's correct. Now again, to check, you can always just distribute. In fact, you should always distribute, multiply backwards, and see if you go back to the original expression. So I'm going to go ahead and do that now in my head, and I can see I already made a mistake. See, I tested it and I saw that this 4 shouldn't be here. I don't know why I wrote that 4. So be sure to always multiply if you have any doubt, and you can go back and fix that. So let's see if I have it right now. That looks correct. Alright, so again we have a quadratic here. But this quadratic is going to be more difficult because we have a coefficient here. So we do have to ask what two numbers multiply to -2, but we can't say that the two numbers are going to add up to 1. Again, the coefficient is not there, but it's assumed to be 1. But we can't do that second part because of that 3 coefficient. So again, this is all review from a previous class. But we're going to write the 2 pairs of parentheses, and we know it's going to be 3x and x. Not just x times x, but 3x times x, because we have a 3x squared. And it doesn't matter if you put the 3 here or here. Alright, so now there's only one option for -2. It's got to be -2 times 1. But we don't know if we should put the 2 here or here. So now we have to use FOIL. And again, we didn't have to use FOIL for this one. I mean, well, I should probably take that back. You probably should use FOIL on this one. But it's pretty much a guarantee that it's going to work because we don't have a coefficient here. As long as we followed the algorithm to factor that, it should work. But on this problem, we really need to use FOIL to check. But we don't have to use the F and the L of FOIL. Again, we just have to use O and I. So the outside terms would be 3x and the inside terms would be 2x. So does 3x minus 2x equals x? And the answer is yes. So that means we got lucky on that problem. Our first try was correct. Now again, if it were not correct, you would just switch the 2 and the 1. And if you got negative x, you would just keep the 2 and the 1 in the same place, but you would change the signs. Again, this is all review. All right, so let's try number 4, and then you can try number 5 on your own. So there's 2 terms, which means it's going to be the difference of 2 squares after we factor out the greatest common factor. And the greatest common factor, I believe, is going to be 9x, and you're left with x squared minus 4. And so, again, we have a difference of 2 squares. This is a square, and this is a square because 4 is the same thing as 2 squared. 2 times 2 is 4. So we're going to have 2 pairs of parentheses and our x and x, and we just figure out what number multiplies by itself to get 4, and that's obviously 2. And then, of course, you put your plus and your minus. You always put plus and minus with difference of 2 squares. All right, so now it's time for you to try. Go ahead and try number 5, and when you come back, we'll do it together. All right, we're back. So as usual, we're going to factor out a greatest common factor, and this was an unusual problem because we can only factor out z's. We have no normal numbers. And looks like that's correct. You always want to double check after you factor out your greatest common factor. And so now we have a quadratic expression. So we need 2 pairs of parentheses. And there's no coefficient on the z squared, so this is going to be pretty easy. We just have to figure out what 2 numbers multiply to 16 and add up to -8. So that would be -4. So if that was your answer for number 5, that means you're getting the hang of it. Now if you got stuck on number 5, that's okay. We're going to do a lot more problems. Alright, so we have 2 terms, so this is going to be the difference of 2 squares. I also want to warn you that we have some pretty big numbers here, so don't be afraid to get out your calculator if you don't want to have to do the math on that. So try number 6, and when you come back, we'll do it together. Alright, we're back. I'm going to try factoring out 2y squared. I'm pretty sure that's going to be correct. And it looks like that's correct. Just double checked it. Check, yep. So now we have the difference of 2 squares here. So we're going to need 2 pairs of parentheses as usual. Again, this is all review. What number times itself equals 25? Well, that's 5y. And what number times itself equals 64? That's 8. And of course you need your plus and minus. Whenever you have the difference of 2 squares, it's always going to be plus and minus. So again, just to review, difference of 2 squares always factors to 2 factors that are exactly the same, no difference whatsoever, except one has a negative and one has a positive. Alright, for number 7, before you attempt it, I just want you to be aware that there's a negative on the first term. And again, when there's a negative on the first term, you want to factor out a negative. It just makes it easier. So we're not just going to factor out the greatest common factor of the normal numbers. We're going to factor out a negative 2. Also be aware that you can use a calculator for this one because we have some pretty big numbers. So try number 7. When you come back, we'll do it together. Alright, we're back. So I think negative 2z is going to be the greatest common factor. And that's going to be 19z, negative 19z, and positive 30. So let me just double check that. That looks correct. So this is a very strange looking quadratic expression, and we have a coefficient here. So that makes it more difficult to factor. We have 3z and z. It's going to make it difficult because we have the coefficient there. And let's try negative 5 and negative 6. They multiply to 30. And so now we're going to have to use the O and I of FOIL. We don't care about F and L because we set that up so that it would work correctly, but we do have to worry about the O and the I of FOIL. So outside terms multiply to negative 18z, and the inside terms multiply to negative 5z, and you add those together and you get negative 23z. So that doesn't work. We need negative 19z. So we can try switching the 6 and the 5. So let's try putting the 6 here and the 5 here. Then we get negative 15z and negative 6z, which add up to negative 21z. So that didn't work either. Again, we want negative 19z, not negative 21z. So looks like 5 and 6 are not going to work. So now let's try 2 and 15. I know 2 times 15 is 30. That's not one of our multiplication facts, but you should be able to figure that out. But we know that's not going to work because O would be negative 45z and I would be negative 2z, which would make negative 50 or negative 47z. It's nowhere near negative 19z. So let's try switching the 15s and the 2. So now the inside terms would be negative 6z. Excuse me, the outside term is negative 6z, and the inside term is negative 15z. Add those together, you get negative 21z. So that doesn't work. So we tried 6 and 5, we tried 2 and 15, and that doesn't work. And I know it's can get frustrating, but it's okay. We're doing well. We're figuring out for figuring out the possibilities. So now I'm going to try 10 and 3. Whoops, I should put a positive there, or excuse me, a negative. So negative 10 and negative 3. Negative 10 times negative 3 is positive 30. So now the outside terms, 3z times negative 3 is negative 9z. Inside terms, negative 10 times z is negative 10z, and we know that these combine to negative 19z. So that gives us the answer. So we had to try a lot of different options on that one. Don't be discouraged if you have to try a lot of different options. That's just something you have to do on some of these problems. All right, so on to number 8. Go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. So I'm going to factor out 4y. And we're left with the difference of two squares. So what number times itself equals 4? That would be 2, but we have to write a y also because the first term has a y. And then what number times itself equals 1? Well, that would just be 1. And then because it's the difference of two squares, we put a plus and a minus. So if you got that answer, good job. Again, a lot of this is just review from the stuff that we did in previous classes. Try number 19, and when you come back, we'll do it together. All right, we're back. So we're going to factor out 3x. And then we have a quadratic expression, so write two pairs of parentheses. And what two numbers, we don't have a coefficient on this squared term, so we can just ask what two numbers multiply to 10 and add up to 7. So that would be 2 and 5. All right, so if you got that answer, good job. So number 10 is going to be the difference of two squares, but I just want you to be aware that you have a negative on the first term. So you want to factor out a negative on this problem. So, and again, you can use your calculator if you think 32 is the number's too big. So try number 10, and when you come back, we'll do it together. All right, we're back. So I'm going to factor out a negative 2. And this problem is unusual because there was no variable to factor out. We only factored out what's called a constant number. If a number doesn't have a variable on it, it's called a constant. All right, so now we have the difference of two squares. So that's two pairs of parentheses, and then x and x, and what number times itself equals 16? That's 4, and then obviously if you have the difference of two squares, it's just plus and minus as usual. So if you got that answer, good job. All right, so for number 11, you might need your calculator because, again, we have 120. So attempt number 11, and when you come back, we'll do it together. All right, we're back. I'm going to factor out a 4y. And I think that should be negative 30. 4 times 30 is 120. So let me double check that, and it looks correct. All right, so now we have a quadratic expression left over. So again, two pairs of parentheses, y and y, and we only have a coefficient of 1 here. It's a very small number, so that means the two numbers that you put here have to be pretty close together. So I know it's got to be 6 and 5. I feel that it has to be 6 and 5. And when you add 6 and 5 together, you get 1. Again, if there's no coefficient, it's assumed to be 1. And so it looks like that works. So if you got that answer, good job. All right, so why don't you try number 12, and when you come back, we'll do it together. All right, we're back. So I think that's correct. Yep, that's correct. And we have a quadratic expression. And this is easy because we do not have a coefficient on y squared. So all we have to do is ask what number is multiplied to negative 8 and add up to 2. So that's going to be plus 4 and minus 2. So if you got that answer, good job. All right, try number 13. And when you come back, we'll do it together. And before you try that one, just be aware, we have a negative sign, so you're going to have to factor out a negative. So try that one, and when you come back, we'll do it together. All right, we're back, so we're going to factor out a, I think we're going to factor out a negative 2x to the 4th. And we're left with 9x squared minus 9x minus 4. So let's double check that by multiplying back. And that looks correct. So this looks like a really strange quadratic. Strange just because I haven't seen that one often. And just be aware that this is going to be harder because we have a coefficient on the x squared term. So we can't just ask what two numbers multiply to negative 4 and add up to negative 9. Again, multiplying to negative 4, that part works, but the negative 9 part, the adding to negative 9 doesn't work. Again, because of this coefficient. If this coefficient were not here, then we could just ask what two numbers multiply to negative 4 and add up to negative 9. All right, so first we have to figure out what two numbers multiply to 9. And there's two options. We can do 3x and 3x, or we can do 9x and x. So I'm going to try 3x and 3x. And now for negative 4, there's two options. We could do 1 times 4 or 2 times 2. So I'm going to try 2 times 2. And one's got to be positive and one's got to be negative because we have a negative 4. So let's see, I'm going to have to test that. Remember, whenever you have a coefficient, you definitely have to, a coefficient in front of the square term, you definitely have to test that. So we're going to test the O. The O is 6x and the I is negative 6x. So that obviously does not work. That's not going to give us negative 9 because that's going to go, 6x minus 6x is 0. So it doesn't look like the 2's are going to work. And if we switch the 2's, it's not going to change anything because we have 3x's on both of these, so it's really not going to do anything. So we know it's not going to be 2 and 2, so we have to try 1 and 4. That was the other option. Now the outside terms, again, you don't have to check F and L, just O and I. Outside terms would be 12x, and inside terms would be negative 3x. And 12x minus 3x is 9x, so bingo, we got it. But we don't want positive 9x. We want negative 9x. So all that means is we have to change the sign. So this becomes a positive over here, and the positive sign becomes a negative sign. So if you got that answer, good job. All right, so let's see here. Try number 14, and when you come back, we'll do it together. All right, we're back. So I think we're going to factor out 7y cubed. And we're left with that expression. But let me double check my factorization before we go on. And it looks correct, so now we're going to factor. So again, because we have this coefficient here, it confuses things. It's going to be harder. So we're going to write 2y times y because there's only one way to factor 2. It's just 2 times 1, so 2y and y. And then here we have 6, so we can do 2 times 3, or we can do 6 times 1. We don't know which one is going to be. I'm going to try 3 and 2. So now I have to test FOIL with this expression. So again, the f and L we don't need to test, but the O would be, the outside terms multiplying them would be 4y, and the inside terms multiplying them would be 3y. And we got lucky because 4y plus 3y is 7y. So we are done with that one. So if you got that answer, good job. All right, so on to 15. Go ahead and try 15, and when you're done, we'll try it together. All right, we're back. So we're going to factor out 5z to the second power. And we have z's second power minus 4. All right, so this is the difference of two squares, which means, again, we did this in a previous class. What two numbers multiply to 4, or what number multiplies by itself to become 4? That would be 2. And of course, when we have a difference of two squares, we always need a plus and a minus. So if you got that answer, good job. All right, so why don't you try number 16, and when you come back, we'll do it together. All right, we're back. Let me just double check that. Everything looks right. We have a quadratic. And it's going to be minus 5 and minus 8. So if you got that answer, good job. All right, on to number 17. Go and attempt that problem, and when you're done, we'll do it together. All right, we're back. All right, so let's multiply back and check our work. And that looks correct. If you have a hard time factoring the quadratic expression, it might be true that you didn't factor correctly. You got to factor correctly on the first step when you're factoring out a greatest common factor, or else you're not going to be able to factor the quadratic expression. So just be aware of that. All right, so let's see, it's going to be 2y and y, and I'll try negative 5 and positive 1. O would be 2y and I would be negative 5y, and it looks like we got the right answer. So I got lucky on that one. My first try was correct. All right, so now we're going to go to something different. Now we're going to have to use grouping. So I want you to be aware that we've used 3 types of factoring so far. We used factoring a quadratic expression. We used factoring the difference of two squares. And of course, on every problem, we factored out the greatest common factor. So out of the 6 types of factoring that we learned, we've used 3 types. Now we're going to go on to a 4th type. And these problems we're going to factor by grouping. But again, the first step is always to factor out the greatest common factor. And in this case, that's going to be, I think it's going to be 2x squared. And then we're going to be left with 2x to the 4th, and so on and so forth. Let's double check that. And it looks correct. All right, so now at this point, we're going to factor the inside part, the part inside the parentheses, by the method of grouping. So I'm going to take these first 2 terms, and I'm going to factor out the greatest common factor of those first 2 terms, which would be 2x cubed. And I'm left with x plus 4. And then on these two terms, I'm going to factor out the greatest common factor. And that's going to be 3. And you're left with x plus 4. Now at this point, you're probably thinking this is getting kind of confusing. And it definitely looks confusing. So what I'm going to do is I'm going to take these outside brackets, or excuse me, the outside parentheses, and I'm going to turn them into brackets because it just makes it easier for us to see what's going on. Remember, we learned that in the arithmetic course, or you may learn that in your arithmetic course, that you use brackets when you have parentheses within other parentheses. So notice that we have a common term here. If you don't have that common term, x plus 4, then you know you did something wrong. So we're going to factor out the x plus 4. Again, this is review from a previous class. And you're left with the x, or the 2x cubed plus 3. All right, so at this point, we just have to do one more step because we don't really need the brackets. So we can just get rid of those brackets. And that would be the final answer. Now I know what you're thinking. You're thinking this is really starting to get confusing. Well, it's really not a big deal. The only difference between what we're doing now and what you did in a previous class, the class on factoring by grouping, is that we're doing an initial step where we factor out the greatest common factor. That's the only difference. So there's really nothing to be afraid of. All right, so, and I noticed I just made a mistake. I don't know why I did that. I put a negative there, so that should be plus. All right, so let's try another problem. And notice we have a negative on the first term, so it's just traditional. It's not really required, but it's traditional to factor out that negative. All right, I think that's correct, but let's multiply back to see if we get the right answer. And that looks, whoops, I don't know why I wrote 5 there. That should be 15. You see, I caught myself. It's so important to multiply back and check, because if you don't factor this expression on the first step properly, you have no hope of solving or doing the rest of the problem correctly. So that's extremely important to do the first step correctly. All right, so now we're going to factor by grouping again, but on the first step I'm going to go ahead and just put brackets. And we're going to factor these first two terms, and that's going to be like so. And then we're going to factor these second two terms, but on the second two terms, there's something important that's going to happen. We're going to have to factor out the negative. We're going to have to factor out a negative 3. And again, we're using brackets. So again, you just want to multiply back using the distributive rule, and that'll see if we did it correctly. So we know that we did this correctly because we have y squared plus 5 and y squared plus 5. We have common factors, so that tells us that we factored correctly. And so now we just have to factor out the y squared plus 5. And we're left with y cubed minus 3. Again, you should be constantly going back and checking all your work. Double checking, triple checking if you need. It's really important when it comes to algebra to double check things. if you have the time. So now we just have to get rid of the brackets. We don't need the brackets anymore. And it looks like that's it. That's the answer to that one. Alright, so now it's time for you to try. I'm going to go ahead and try to leave 18 and 19 in the window here so you can see those, and that'll help you with number 20. So go ahead and try number 20. I know these problems look pretty intimidating, but I think you can do it. Try number 20, and when you come back, we'll do it together. Alright, we're back. So the greatest common factor is going to be, let's see here, looks like it's going to be 3, I believe, and x cubed. And I need to make sure that I did that correctly, so I'm going to multiply back. And that looks right. So now I'm going to factor by grouping. Whoops. I'm going to try to keep that in the window, sorry. Put your brackets. Factor out the greatest common factor from the first two terms. That would be 2x squared. And factor out the 3, and you get 2x plus 1 in the second two terms. And that's a good sign because it looks like we have the common factor there. Let's just multiply back just to make sure it's correct, and that looks correct. So now we're ready to factor out the 2x plus 1. And we're left with 2x squared plus 3. So now we just have to get rid of those brackets because we just don't need the brackets. You always want to make your expressions as simple as possible. So because we don't need those brackets now, we can just get rid of them. So if you got that answer, good job. Alright, so try number 21, and when you come back, we'll do it together. And remember, we have a negative, so you're going to have to factor out a negative. Try that problem, and when you come back, we'll try it together. Alright, we're back, so we're going to factor out a negative 3y to the third power, it looks like. And I'm going to multiply back to check my work. And looks like that's correct. Whoops, I'm going to keep that in the window, sorry. Put your brackets. These problems are very intimidating, so I'm color coding to show you where each term is coming from. That looks correct, and it's a good sign because we have a common factor, y minus 3 and y minus 3. Again, if you're having trouble factoring this, it's probably because you didn't do the first step properly, so just be aware of that. That's very important. So now we're going to factor out the y minus 3 from both those terms inside the brackets, and we're left with y squared plus 4. Now we just have to get rid of those brackets because we just don't need them. And there you go. So if you got that answer, good job. All right, so let's see what we have next. So this problem is going to be a little different. We're going on to another type of factoring. So far we've done factoring out a greatest common factor, quadratic expressions, difference of two squares, and factoring by grouping. So we have two more types of factoring. So we're going to introduce one more type here. So let's do this one together. This is the type of problem where you're not going to see it very often, but you may see it at least once here. All right, so in this problem, we're just going to factor out a negative x. All right, let me double check, multiply back, see if I did that correctly. And it looks correct. All right, so you can see that this is a different problem because we have, instead of a squared term here and a first power term, we have a fourth power and a second power. So this is a special type of factoring that we did in a previous class. So what that means is instead of a 2x and an x, we're going to have a 2x squared and an x squared. We have to square those two. Again, you're not going to see this type of problem very often, but you will see it eventually. So now, what two numbers multiply to negative 44? Now the two numbers are not going to add up to 3 because we have a coefficient here. But we do need to figure out what two numbers multiply to negative 44. So let's see, I'm going to try 11, negative 11, and positive 4. So O and I, a FOIL, we have to check. So O is 8x squared, and I is 11x, negative 11x squared. So that becomes negative 3x squared. Bingo, we have the right number, but we just don't have the right sign. So that what that means is we have to change this sign to a positive, and we change the other sign to a negative. But unfortunately, we're still not done. The reason we're still not done is because this just happens to be the difference of two squares. So remember, you always have to factor completely. Sometimes these problems kind of just go on and on and on. So when you have the difference of two squares, you need two sets of parentheses. What number times itself equals 4? Well, obviously that would be 2, and you put your plus and minus. So that was a challenging problem. That's probably one of the hardest ones we're going to do. All right, so now why don't you try 23? 23 is going to be a similar problem. Again, we're not going to get very many of these, but we see 112 here, so you may want to break out your calculator. So try 23, and when you come back, we'll do it together. All right, we're back. So we're going to factor out 4z cubed. And 112 divided by 4 is a 28, I believe. Yep, that's correct. And again, this is a quadratic, but it's a special type of quadratic because we have a fourth power and a second power. That's different. Again, we're not going to do very many of these because they're not that important, but you will see them. So instead of a z and a z, instead of just writing a z and a z, we're going to write z squared and z squared. And let's see, I'm going to try 4 and 7, because 4 times 7 is 28. And again, there's no coefficient here, so we know that it's just two numbers that multiply to 28 and add up to 11. So that would be 4 and 7, it looks like. Now, in the previous problem, we factored x squared minus 4. Now we have z squared plus 4, but z squared plus 4 cannot be factored because it's not the difference. It's a sum, it's not the difference. It's the difference of two squares. So only a difference of two squares can be factored, not a sum of two squares. So if you got that answer, good job. All right, so 24 is going to be a little different because you're going to have kind of the same situation. So let's try it together. You're going to factor out 5z cubed, and you're left with z to the 4th power minus 1. So the reason that this is different is because we have the difference of two squares, but it doesn't really look like the difference of two squares because we have z to the 4th power. So this was that special type of problem that we did. Again, this is just a beginning algebra course, so we don't really have time to go into a lot of advanced type of factoring. So I don't want to overwhelm you with a lot of weird problems. But it's just going to be z squared and z squared again. And we have the difference of two squares, so it's just what number times itself equals 1. And of course that would just be 1. So again, it's a difference of two squares because z squared squared is just z to the 4th, because z squared squared is just z squared times z squared, which is z to the 4th. All right? So at this point, we have to keep going because we have a difference of two squares. Obviously, that's not the difference of two squares because it's addition, but here we have subtraction, and we also have perfect squares. So z squared minus 1 is going to be z minus 1 times z plus 1. So again, that was a different problem from the normal difference of two squares because we had a 4th power. So why don't you try number 25, and when you come back, we'll do it together. So we're going to factor out 3x squared and again, we have the difference of two squares, but x to the 4th doesn't look like a square. So we have x squared and x squared instead of x and x. What two numbers multiply to 16? And obviously that would be 4. And because it's the difference of two squares, we always put plus and minus. Now at this point, we have to keep going because this here is the difference of two squares. So that becomes x minus 2 and x plus 2. And that would be the final answer. So if you got that answer, good job. Now if you stopped here, it's not wrong, it's just you didn't continue to factor. Alright, so we're going to continue on here. So for 26, we now have more than one variable. So the first step, as usual, is going to be to factor out the greatest common factor, and that's going to be 2. The smallest power of a is a squared, and the smallest power of b is b to the 5th. So that's the greatest common factor that we factored out there. And now it's going to be, again, we're going to ask ourselves, 2a squared b to the 5th times what equals 2a to the 4th b to the 5th? So that would be a squared, it looks like. And 2a squared b to the 5th times what equals 16a cubed b to the 6th? So it looks like that's going to be 8ab. And 2a squared b to the 5th times what is equal to 24a squared b to the 7th? So that's going to be 12b squared. So we've done, I think this is the last type of factoring. We did factoring quadratic expressions, difference of two squares, factoring by grouping, factoring out the greatest common factor, factoring the special case of x to the fourth and x to the second power, and now we're on to factoring expressions with two variables. So that's 6 different types of factoring, if I counted that right. So now we have a quadratic expression with 2 variables. So we did this in a previous class. It's just going to be a, and what 2 numbers, because we don't have a coefficient here, it's just going to be what 2 numbers multiply to 12 and add up to 8. So obviously that's just going to be 2 and 6. But because we have b's, we have to write 6b and 2b. And we're going to have a plus signs there. All right, so let's rectangle that one. So on to 27. Again, first step is always to factor out the greatest common factor. You can get your calculator out if you need to. So I'm going to double check and factor or multiply back. That looks correct. So now we have the difference of 2 squares, but we have 2 variables. So that's what's different about these problems. Difference of 2 squares, but with 2 variables. So it's going to be x and x, and what number times itself equals 25? That's going to be 5. But we need a y because it's negative 25y squared. So there we go for that one. So let's try 2 more of these before you try some on your own. Now we have a negative on the first term, so we're going to have to factor out a negative. Again, we don't have to factor out a negative, but it just makes it a lot easier to visualize. So again, I found the smallest powers for each variable, and I just figured out what's the biggest number that goes into all these, and that's going to be 3. And of course, I factored out the negative. Whoops, I should need a 2 there. And I'm going to need a 5. And I think that's correct, but let me double check. I'm going to multiply back in my head. A lot of stuff going on here, so you really need to be careful. And that looks correct. So now we can continue. So this is a quadratic expression with two variables. But the problem is we have a number in front of here, so that's going to present a problem. So it's going to be 2c and c, and what 2 numbers multiply to 3? That's just going to be 3 and 1. But we have to test this because the 3 might go here. We don't know where it's going to go. So test O and I of FOIL, you get 2CD and 3 DC or CD, it doesn't really matter which order. And so if you combine those, 2 minus 3 is negative DC, and we don't want negative DC, we want 5 DC. So that didn't work. So let's try switching the 3 and the D. All right, now O would be 6D, and I would be DC, 6DC. and I would be 1 dc, so that would subtract to 5 dc. And that's exactly what we want, 5 dc. So we know it's correct now. Now we just rectangle that answer. Alright, so we'll try one more of these before you try one on your own. So I'll factor out CD squared. And you're left with that expression. And we have the difference of two squares, but now we have two variables in the difference of two squares. I should probably write that a little bigger. Alright, so there you go. So we have the difference of two squares, so you just have to figure out what number times itself equals 4. And then you write your C's and your D's and make sure you write a plus or minus, because whenever you have the difference of two squares, it's going to be plus or minus. Alright, so now it's time for you to try. Go ahead and attempt number 30. Again, it's the same thing with all these problems. You got to factor out the greatest common factor in the first step. So do that, and then factor your quadratic with two variables, and when you come back, we'll do it together. Remember, factoring out a quadratic with two variables and factoring the difference of two squares with two variables is just review. So I'll see you when you come back. All right, we're back. All right, now I'm going to multiply that back to see if I did it correctly. And that looks correct. All right, so we have a problem here because we have a coefficient on the squared term. So it's not going to be multiplying to -2 and adding up to 1. Well, actually, it is going to be multiplying to -2, but it's not going to add up to 1. All right, so we have multiple options for 6. That's important to understand. You can write 2a times 3a because that's 6a squared, but you can also write a times 6a, or 6a times a, same thing, because 6a times a is 6a squared. So we don't know which one it's going to be. So let's try 6a times a, and here we only have one option really. It's just going to be -2b and positive b, but again, we don't know where the sign is. We don't know if this is going to be positive or negative. We don't know if we should put the 2 here or here, so we have to check with FOIL. So we don't have to use F and L, but we do have to use O. So outside terms is going to be 6ab, and inside terms is going to be -2ba. 6ab minus 2ab is 4ab. So we didn't get the AB. We don't want 4AB. We want just AB. So I know if I change the 2 here, that's just going to make the problem worse. We're not going to get anything close to that. So what we have to do is we have to change the 6 and the 6a and the a and make it 2a and 3a. So now let's try the O and I of FOIL again. O would be 2ab and I would be -6ab. And you can see we're going to get -4ab. So that didn't work at all. So now we have to try something else. So the only thing that I can think to try now is to switch the 3 and the 2. We'll make this 2a and we'll make this 3a. Now this should work. But we might have to, we can still switch the 2. So if this doesn't work, we still have one more option. So O would be 3ab and I would be 2b. Actually, no, it would be -4ba, And again, it doesn't matter the order of these letters. They're all the terms are still the same. All right, so 3ab and negative 4ab, and that would give us negative 1ab. Bingo. That's the number we want. The only problem is we got the opposite sign. We need a positive ab, not a negative ab. So all we have to do is take these signs and just switch them. So we'll change this sign to a positive, and we'll change this sign to a negative. And there we go. So if you got that answer, good job. All right, on to number 31. Go ahead and try 31, and when you come back, we'll do it together. All right, we're back. And we get 16. That's the difference of two squares, so what number times itself equals 16? That would be 4. And of course we need the positive and the negative. So if you got that answer, good job. All right, for number 32, remember we're going to have to factor out that negative because we have a negative on the first term. We don't want a negative on the first term, so try number 32. When you come back, we'll do it together. All right, we're back. So I'm going to multiply back to check my answer there. That looks correct. We have a quadratic expression with two variables, but we do not have, we do not have a coefficient on the squared term. So that means that it's just what two numbers multiply to 12 and add up to negative 7. So it looks like that's going to be, that's going to be negative 3y and negative 4y. So if you got that answer, good job. All right, on to number 33. Go ahead and try 33, and when you come back, we'll do it together. Remember, you have to factor out that negative on the first term. All right, we're back. Let's double check. That looks right. And now we're just going to factor 4x squared minus 9. That's difference of two squares. What number times itself equals 4? That's 2. What number times itself equals 9? That's 3. So if you got that answer, good job. All right, try number 34, and when you come back, we'll do it together. All right, we're back. And it's always good to double check. And that looks correct. Again, if you don't do the first step correctly, you're not going to have much chance to, well, it's pretty much a guarantee you're not going to be able to do the rest of it. So it's a good thing because we don't have a coefficient in front of the a squared. So we just ask what two numbers multiply to 15 and add up to 8. So that would be 3b and 5b. And yes, that's correct. So we got that answer. Good job. All right, try number 35, and when you come back, we'll do it together. All right, we're back. Let's see here. I think it's going to be 4 x to the 8, y to the 6 is the greatest common factor. Let me just double check that, multiply back. That looks correct. And this is the difference of two squares with two variables, so what number times itself equals 9? That would be 3. What number times itself equals 4? That would be 2. But again, because you have two variables, you have to write your y also. And difference of two squares, just plus or minus. So if you got that answer, that's very good. Good job. All right, so it looks like we have 2 more problems here. You're doing good. Try number 36. And when you come back, we'll do it together, but just be aware, you got to factor out that negative because we have a negative on the first term. I'll see you when you come back. All right, we're back. And I think that's correct. Let me double check. Actually, that is not correct. I need a y to the 4th on the end. You see how I caught myself? You gotta double check when you're factoring out the greatest common factor. So let me check that last term now. Looks correct. All right, so we got a quadratic expression with two variables, but it's good news because we don't have anything on this first term. So it's just what two numbers multiply to 8 and add up to -6. Then we have to make sure to put our two variables. So that's going to be -2 and -4. So if you got that answer, good job. All right, so number 37. Try number 37. When you come back, we'll do it together. All right, we're back. So in this case, it looks like all we're going to be able to do is factor out variables. We cannot factor out any numbers. And then we're left with 25c squared minus 4d squared. And let me just double check that. And that looks correct. So that's the difference of two squares. What number times itself equals 25? That's 5. What number times itself equals 4? That's 2. And there you go. So if you got that answer, good job. So that was the class today. So that's one of the most challenging things we're going to do when we're using all these different types of factoring. And we had 2 variables, and we had all kinds of crazy stuff going on. So this is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that. Now don't go before you get your homework. Here's the first couple pages of the homework. Be sure to get screenshots of that. And here's the answers to the homework. Remember, it's not enough to just attempt the homework. You must do it correctly. If you get the wrong answer, don't just go on to the next problem. Figure out what you did wrong and correct your mistakes. The homework needs to have those 4 characteristics. It has to be correct, complete, neat, and in order in your binder. And remember, if you don't do that homework, or if it doesn't fit one of those 4 characteristics, then this course is just a waste of time. You're not going to learn anything. So get that homework done, and I'll look forward to seeing you in the next class.